All right, everyone. Welcome back. I think we're back live. Supposed to video. So let's see, I have the great pleasure to introduce your moderator for the first session this afternoon, Vadim Igorovich Gushin. You all know he's the deputy head of the psychological department for IBMP, of course. He's an MD, also has a PhD in aerospace psychology. He has certificates in psychotherapy, and not a surprise if you've talked to him because his English is excellent. It's perfect, probably better than mine. A certificate in English. He has worked extensively with all the major space agencies, including, of course, NASA, ESA, and the Canadian Space Agency, and JAXA as well. He is an expert on analogs, which is fitting, of course, because that's what this session is all about, and analogs including the Antarctic, which we just saw some videos of, Mir space station and ISS used as analogs in certain research projects, and of course chambers. He's had extensive work in chambers, working in experiments with chambers, including of course Mars 500, which was a very extremely successful. So please help me welcome Dr. Gushin.
Actually, as a moderator, I'm now again wearing a mask of academician Morokov, and just let me remind you about his main features as a specialist in analogs. He is a world record holder in the duration of bed rest. 1 year bed rest was executed under his guidance, and of course he was the top manager in Mars 500. So he is holding both world records in the both most long analog studies here on Earth. And of course, I'm not capable to substitute him, but I will try. So let me, again, this each moderator is trying to impose his own rules of the game. My rules are that we have themes in the list, but I don't want everyone to speak about everything. So I'm asking several colleagues, I'll name them, of course, to first start talking about desired characteristic of analog. And from that point, I prefer to ask to speak my distinguished colleague David Dinges and Inessa Kozlovskaya. And let me explain why. I think these two outstanding scientists, they know what they want to have on Earth as an analog of space flight, and I think they have the best vision what we desire to have as scientists as an analog. So each of you is having at least 3 minutes, but if you want 5, you will have 5. David, I'm sorry,
Vadim,
but ladies first.
Vadim, thank you very much. I'm very grateful to you for giving me word, and I will not take this long time, because the analog about which I wanted just to make a statement, it is not usual, because it is not even cited along the analogs which are shown in the schedule. The point, we understand that there are a lot of analogs, and they actually mimic or simulate some of effects of human flights or weight and it could be isolation, and it could be some psychological stresses and so on and so on. But working in physiology, we were almost interested in weightlessness and the effect of hypogravity, and we were working with all models of microgravity on human beings and on animals, and working both in real weightlessness, in real flights, and all these analogs. We have found that one of the most powerful analog of weightlessness is immersion. And for almost 30 years, we are working with immersion using the model which was developed in Russia, which is free of those discomfort effects which close contact for a long time with water can produce. This is called, that's why it's called dry immersion. And I would not go in detail of this. Everybody can read who will be interested in it. It is bath which is filled with water, but there is a lot of tissue there, waterproof tissue, so which is just swimming there, and the person is not in the water, but he is surrounded by the tissue, but the effect is exactly the same. So the weight is distributed equally around the body, reproducing the effects of hypogravity, and working very precisely with completely different function, comparing the very same duration of flight effects with the very same duration of bed rest effect, with immersion effects, and in animal, not only in human being, but in animal, I mean in monkey, we have found that effects of immersion, at least in central nervous effect and the sensory motor effects, are one-to-one as weightlessness. It is depth, speed of development, speed of rehab, and so on and so on. Bed rest shows the same effects that in tendency, but timeline of development are uncomparable. The changes in muscle, which we obtain in immersion in 10 days, they are equal to changes in muscles which we obtain in 60 days. The decline is muscle tone, which is developed in space and in immersion in 6 hours. But the decline of tone up to 40-50% in extensors. In bed rest, it comes to 25% up to into 40-45 days, and so on. And using this model, this analog, for developing of new countermeasures turned out to be extremely successful. I will not tell you the all things which were discovered there of mechanism of effects of weightlessness on human body, but using these knowledges which we obtained in all this situation, we developed up to date. We already developed 3 new countermeasures, which are already on our station among those mean which we suggested for our cosmonaut. Thank you very much.
Спасибо, Miss Benedictovna. David, it's your turn. What's your cherished desire to have as an analog for your research?
Thank you, Vadim, and I want to thank the organizers for inviting me. This has been a very stimulating meeting, I think the best I've attended. I do have opinions in this area. The first is actually the people. Astronauts are special people. They have to be capable in a great many areas. They're dedicated to the mission. They're aware of the risks. And we ask them to do remarkable things. In the area of human behavior, if you're studying people who either are astronauts or very similar demographically to astronauts, I think you have a much better opportunity to identify what you're going to have to, how resilient they are, what you have to provide as countermeasures, and what kinds of behavioral issues and physiologic issues, et cetera, may come up. As the population becomes more dissimilar from astronauts, you have more error variance. You don't know what it means. Now, we've actually, we not only know this from laboratory studies, we've done 4 NEMO missions and desert rats and hot and Mars, and of course the Mars 105 and the 520. And there is no question that when you're, and ISS, and when you're studying astronauts or astronaut surrogates, and I consider the crew members of Mars 520 to be astronaut surrogates because they had the demographics of that and the commitment. But when you get into and Nemo were astronauts, but when you get into populations that are not, and you're measuring them, you quickly see in the behavioral domain, whether you're talking about overt performance, adherence to schedules, self-ratings, the degree of instability in various things, impulsive behaviors, you see that astronauts are different. They're more alike. There's less inter-subject variability in certain ways in their base capability. And they're tougher. Even if they're mad at you, they'll do what you ask them to do. They're committed. And so for me, at this point in the issue, I can get what are the biological limits of humans in my laboratory of the average human. But if I want to know what's going to happen to astronauts in confinement, I want to get as close to astronauts as I can get. So I view the people we study as analogs too. They're analog people, and I want to see engineers in that. Now, once somebody said, well, why not study scientists? Well, actually, we have, and they're not astronauts, and they're not really terribly good analogs. They're similar in some ways educationally, but they're very individualistic. They come with a lot of other error variants. So it really does have to be people that have those characteristics. So for me, that's actually the most important thing. And then I would just add secondarily, the fidelity of the mission and where it's located, whether it's at Devon Island or whether it's under the ocean or whether it's at IBMP, that's important, but not as important as the fidelity of the overall context. Having a mission control, having clear expectations, selection, work, creating a high fidelity environment, regardless of duration, really does matter here. Because you want to see what astronauts or astronaut surrogates are going to do in a high fidelity environment. And so those two things matter a great deal to me. And then everything after that, mission duration, the degree to which you provoke the situation with emergencies or other things, those are more specific scientific questions that have to do with how often you can measure and whether you can predict a trajectory of change over time, et cetera. But Dr. Leviton's here in the audience, BHP, and she knows I've said this to her repeatedly. Sometimes she'll say, well, that would be a good analog, and I'll say no, because the people in that analog are not the people that we're going to send to space. And in behavior, I want to study the people who trained and committed to it and have passed the test to go. So that's the issue for me. Analog astronauts are real astronauts, and then high-fidelity missions. 520 was a high-fidelity mission, and I think it succeeded because of that.
Thank you very much. And let me move to the topic number 2. And it's called International Space Station as a possible analog. And I change the people who are speaking, and I want to start with my distinguished director, академик Ушаков. Игорь Борисович, пожалуйста, МКС как аналог возможно.
International Space Station is possible analog, and for what?
And also, Jackie, you have to prepare. You are the next speaker about it.
Добрый день, добрый
Good afternoon.
половина дня. Ну, жизнь так устроена, что человек часто
Life is such that
понятиями,
we think in analogs oftentimes.
аналоги везде, где нужно.
We're looking for analogs
Конечно, занимаемся делом.
everywhere we can, or everywhere we should, and even everywhere we shouldn't.
Смотрели хороший фильм о
We had an opportunity to see a very interesting
нормальных условиях, об
video just now about
марсианской экспедиции.
analogs
Экспедиции.
of some of the conditions that can be present during Mars mission, maybe ISS.
Мы ищем аналоги каких-то физических факторов.
We're looking to simulate various physical factors or conditions that will be present there, and we're looking to develop
Инесса Бенедиктовна Козловская.
countermeasures to these factors. As Dr. Kozlovskaya was saying,
Ну, иногда их называют в
we're
медицине.
looking to study the effects of microgravity
Мы пытаемся создать,
and so forth.
получить
So
у человека
we're trying,
в экспериментальных
using analogs,
целях того, чтобы
to
защитить его от
receive test data that would allow us to protect human beings in actual
сходный симптомокомплекс, сходный синдром
missions or conditions
физических факторов. Вот эту
So-
синхроносходность нам нужно
We need to be able to simulate
к космическому полету. Я
conditions and response to those conditions in our analogs. I would like to go back to the topics of discussions that were brought up yesterday during our first panel. And I know we were just warming up at that time,
может быть, не успели подвести все итоги
and maybe we didn't have a chance to draw all the conclusions from those discussions. But
нашего
one of the main discussions pertain to a year-long flight.
вопрос, что такое годовой полет, который состоится уже
So,
весьма скоро.
What is this year-long flight?
Это
It's going to happen pretty soon. We're already in preparation stages to that.
вперед,
Is it a step forward? Is it marching in place? Or is it something else?
была на первой панели, она, в общем-то, позволила
The
ответить
discussions we had during
на вопросы.
first panel allowed us to answer some of these questions, and I would like to take a couple of minutes to maybe go over
Экспедиция
some of the conclusions that could be drawn from
годовая
that
экспедиция на МКС, которая будет
and talk about the
российской
ISS missions, year-long ISS mission that will have both Russian and USOS crew members.
интегрированной научной программы, она
We're
будет,
already designing mission program
по крайней мере,
for that.
экспедиции на Марс, ну, по крайней мере,
And this program would be a pretty good analog
естественно, в условиях годового
for
полета
Mars mission.
смоделировать экспедицию в оба конца не представляется возможным.
I don't think we'll be able
Прежде
to
всего,
use it as an analog for a Mars mission
медицинские риски
going both ways, but at least maybe going one way. So
длительного
I know that
полета
first priority is given to
экспедиции.
various medical conditions, medical events,
Риски, которые мы
and risks associated with it.
понравился график, который привели американские коллеги во время телемоста
I
Хьюстон-Москва, который
Really like what our US
где
colleagues were saying during Houston-Moscow telecon at the beginning of this year, when we were trying to see what will be happening to risks. Is the number of risks going to be increasing with the increase of the mission duration? Is it going to stay the same, or is it going to actually decrease?
Ну, как минимум, можно, наверное, прогнозировать все
So,
удвоение рисков
I think that at this point we can say that the risks will double
с тем, что, ну, человек,
due to the fact that
который имеет
a human being is a complex system
получить травму,
who is always at risk of getting sick, getting injured,
то это не то функциональное состояние, которое должно быть
or maybe get into a state
физиологов и
that doesn't allow them to do their work and merits attention from doctors or psychologists.
риск
So all these risks were already discussed, and we also discussed the risk today of intracranial pressure and visual impairment. And all of that
что это будет
would probably be
далее.
assessed and evaluated better after we have this analog.
Плохая модель, неплохой
So
аналог
a year-long flight
межпланетного
is a
полета,
pretty good analog for interplanetary missions
более длительного действия космической радиации, которая,
because we will have an opportunity to study
дело с орбитальным полетом, но тем не менее
longer exposure to radiation
получаются, они, в общем-то, являются
and the effects of that.
достаточно значительными, ну и находятся
And we know that the effects may be very significant.
в пределе мер вмешательства, они, конечно, не будут
Of
превосходить
course,
уровень.
they're not going to
Это тоже очень важно. Мы
exceed the levels that would require some kind of interference. However,
радиации.
radiation may be significant, even though we're not going to go beyond the low Earth orbit. So it's not like interplanetary flight in that sense. Also, it would allow us to combine our medical resources, integrate our efforts.
На длительный полет
I think that a long-duration mission to Mars that we talked about today
Уильям Герстермайер,
is a good thing, and
который мы сегодня слышали, это значит, что мы все-таки думаем
Gerstermeyer had a lot to say about that, and it was very useful information. I'm glad that we're thinking about it.
полета на
So,
Марс. Вот объединение этих международных
I think that if we
усилий, в
look
том числе и международных
at the opportunity
является хорошим критерием
that this analog provides us with in terms of integrating international efforts,
эффектом является
especially medical efforts,
согласие биологов
then we can, of course, achieve great results.
того полета. Ну, здесь, наверное, этого не будет. Вот,
It would be interesting to see if we could integrate life sciences. I know Dr. Bogomolov was saying that it would be great if we could have a crew that consisted of
это тоже
MDs and PhDs in life sciences, especially if they would also have some kind of education in engineering, but that's not likely to happen.
необходима, конечно, важность психофизиологических.
Of course, it's very important also to keep in mind how we're going to select the crew, how we're going to train them.
Хорошо ли, что
I gave a lot of thought to the following.
наши руководители, руководители агентств заранее объявили экипаж
Would it be a good idea to announce
года, объявили
crew members
годового полета? И
for the year-long flight in advance, a year in advance, 2 years in advance? And I thought that maybe it's not the best approach because a lot of things can change in 2 years. However, there are some benefits to this approach because during this time,
психологическая притирка, она не всегда даже будет носить точный характер, она будет
candidates or crew members can get
интересоваться друг друга, интересоваться,
used to the idea of going away for
которых предстоит работать.
this long time. They can get used to their partners that they'll be working with for a year. They'll also have an opportunity to meet those crew members that will be coming on board the station and living over
Опять же, Инесса Бенедиктовна Козловская
the year that they'll be there.
в главном результате
And going back to what Dr. Kozlovskaya was saying,
в исторических годовых полетах о том, что
if we look at the historical data for year-long flights,
состояние
we
здоровья
can see that
длительности, как от качества профилактики,
the effects of these missions on human health
систем профилактики, а это также будет
are dictated not so much by the duration of those flights, but the countermeasures that were used by crew members.
выразить
So to summarize,
годовой полет
I just wanted to say that I hope that the year-long flight
в этом году,
that's scheduled for 2015,
2 года,
so pretty soon, in less than 2 years,
модели межпланетного
will be a very good analog
точки Лангранжа
for
на Марс
interplanetary
явится новым
interplanetary missions, maybe Mars mission. So it will be a step forward in space exploration and research. Thank you.
Thank you very much. Chiaki, what's your opinion? How much ISS is an analog and for what?
Well, to answer the question about how much, I think the ISS is the best analog for future exploration that we can have right now. From the viewpoint of such as environment like microgravity, it's a real microgravity, and the radiation and confinement, and also the crew is true crew. So we cannot expect more than this for the analog environment for future. And also from the viewpoint of developing countermeasures, like for example, some physiological the negative aspect from the caused by microgravity. As Dr. Ushakov mentioned, 1 year mission is such a wonderful opportunity. And also the radiation, again, 1 year mission, the crew will be exposed to longer low dose, the long term, the exposure of the radiation, which is good. And then also I'm very much interested in the light therapy countermeasures, because thanks to the changing of the light, the feature from the fluorescent to the LED, now we can control not only the intensity, but also the wavelength, so that we can find out which kind of the lights are very, very good for the countermeasures. And then the environment-wise, like ISS has been quite long, so that maybe the microbiological issue, the change, the surface, or maybe it's the bacterial condition of the surface has been changing. Maybe we can say it's becoming dirtier or close to the Earth environment. So I think to understand the interaction between the the bacteria as well as the crew biofilm is also a very interesting issue. So I think it is a great opportunity. And also, again, one other thing is a technical issue. Like, for example, JAXA right now has the onboard diagnostic kit that we are trying to develop. And then the final goal for this onboard diagnostic kit is to seek the autonomy of the crew to be actually diagnosed based on crew will not be able to be supported by the ground, because if we just think about the Mars mission, I think the capability of the telemedicine is very limited from the ground support. So the autonomy to developing the autonomous the medical kit and the medical technologies is very important. The one thing, the one thing that I think the missing for the analog for developing some countermeasures is the artificial gravity. I think it's to me for long-term mission, artificial gravity, which we don't know which level of the gravity that we need is necessary. And so if we can just utilize some human centrifuge on board the ISS, then I would think it would be best complete the wonderful analog for future exploration.
Thank you, Chiaki. I'm sorry I didn't tell before to our distinguished astronaut. That's the position of the astronaut. If ISS is an analog or something which is precious as it is and cannot be regarded as an analog, what do you think?
Well, so this is an unflown astronaut addressing you. So I'll give you the perspective that I have on this. I like the word high fidelity as a requirement for a valid analog. But I want to pose the following question, just maybe reframe things. When we talk about an analog, what is the purpose of the analog? Are you trying to improve operations, so for the control team? Are you trying to help train an actual crew? Are you trying to simulate medical effects? So I think that drives what a good analog is. And so certainly ISS is a extremely high fidelity analog for space operations, being in space. And it's and the one thing, and it's a great place also to train the crew for, if not the crew that will go to Mars, but a realistic crew. I had the chance to participate into an ESA training called CAVES. And I could compare that to NEMO that I also participated in. And I want to share one nugget with you here. CAVES, of course, is not very high fidelity. You're just spelunking for 10 days, a couple of kilometers inside a mountain. But it has one thing that none of the other analogs that I've heard of have. There is nothing fake about it. It is just a real, mildly dangerous scientific mission. You're camping and you have to do research. So in terms of psychological training, it is extremely high fidelity though. So depending on what you're trying to improve in your understanding, I think that might help determine what a good analog is. Because of course, the human soul has a lot of resources when they're pushed into a corner. And one thing that a lot of analogs, I think, do not have and are very low fidelity is this kind of animal crew motivation that they're embarked on a great journey. I think if you're having a hard time on your way to Mars, you can probably reason yourself that, hey, I'm on my way to Mars. And that is difficult to simulate in another analog. But if you are in a training like CAVES, where you're not trying to play astronauts, you're just trying to practice those skills of doing science in an international team in a difficult environment where you're disoriented, then it's actually a very good high fidelity for crew training. So,
Thank you very much. David, your comment, please.
I think this is an extremely important point, and it's the issue of what is appropriate for training. And this idea that we're going to send people to Mars confined for 17 months, but we're going to train them in the great outdoors. I'm dubious. I mean, just as a behavioral scientist, I'm telling you, I'm dubious. I want to see them, how do they do for 3 or 6 months in a confined space before they go into space? I want to know, because we already know from 520 people begin to adapt differentially, and the trajectories stay that way. Those that don't adapt well continue not to adapt well. And we have enough data off of ISS now, I can assure you that's also got problems. The problems are, we're talking to them constantly. It's like being home. They're on the phone with their families. That's not long space flight. That doesn't simulate the reality of it's just us. We're out here all alone. And we got to figure out how to do this now. We're committed to it. It's all equally heroic, but if you want to know what's going to happen to behavior, you need to study the context that behavior is going to be carried out in, and that behavior is the behavior of performance, successful mission. Now, you can simulate health conditions with some of these features, but you want to study behavior, you need confinement, pressure, time delays, get to goal, unpredictable events, and you can't be holding their hand all the way. In fact, you shouldn't micromanage them. We need to go into that domain. If we're talking, I don't mind if we talk about space, just don't use the word exploration, because we're just driving around the block right now. If you want to go somewhere seriously, start to do experiments that involve true exploration, which means we're not there to hold their hands. And we've got to give them some autonomy. We have to insert time delays, and we got to keep them confined. I have a different view of this. My job is not to make astronauts happy. My job is to make them perform optimally, as happily as they can. Okay, and I've got to, no matter how motivated, remember the traditional models that we're using are 100 years old. And they're the models that say, we'll pick the right people and we'll train them the best. Now, along comes biological limits and differential vulnerability and omics and other things, and that says, well, wait a minute, 50% of the variances is unconscious, unknowable biology that you can't introspect subjectively. And training only goes so far. That's a state variable. It's a good thing to do, but frankly, the more you train in the context, and the military knows this, train in more realistic contexts. The more realistic they are, the better the performance, the outcome you get. So I would argue analogs have to reflect what we expect to happen going to Mars or to explore the universe. If we just want to keep going around Earth, you can just keep doing what we're doing.
Okay.
Excuse me, in the first then check.
I agree completely with you that when we use the analog, we should to use it properly. It means we have to know what really do we use this analog for. It means, like when I talk about the analog for weightlessness, first of all, I say, what do I have to replicate, to replicate? What is weightlessness? Weightlessness is hypokinesia, hyperloading very much, upload, and actually outloading, deloading whatsoever. Axial, whatever loading we have, loading is out. Yes? And no movement. Unfortunately, in space we don't have no movement. But whenever we use on the ground, we use hypokinesia like analog of declining movements, like dynamic unloading. Okay, so I reproduce it. What for? I want to see first of all, if I take just this as a reason, will I have exactly the same effect? If I do have the effect, then it means that under this situation, I can analyze and find the mechanism of what's going on. And then to prove that I found the proper reason, I try then to, introduce this factor back, and if it works, if it take away the results, that's it. So I use it as an instrument for two things, for study mechanism and for development of countermeasure. But if you are telling to you, if I will talk like Dr. Dinges says, it will be exactly the same. I can use the hypokinesia to train, but not performance, but to train the regulation system, control system, for in advance. That's what we are doing also.
Можно я вас прерву, потому что мы иначе не укладываемся. Chiaki, please.
Yeah,
Yes.
I was going to say that David Sanjak made a very good point. When we think about the fidelity, we have to think about the different environments, like microgravity. The different environments means environment that space environment can give us. Microgravity, radiation, confinement. And then I have a question to the other Dr. Dinges. Among these three environments, microgravity, radiation, the space radiation, and confinement, I guess the confinement is the easiest the environment that you can develop, because as Anessa mentioned, microgravity is very difficult, but this confinement for the human performance or training-wise, I think you should be able to develop the good environment even on the ground, because you don't need any microgravity, right?
Yes, absolutely.
Okay, let me stop your discussion in this area. We have to move to the next one. And there are two people here who participated in Mars 500. And my question is a little bit different from that in the list. I don't want the whole follow-up from David and myself. Now I'm not Boris Morokov, I'm Vadim Gushin. And I want us just to try to tell to the audience what we can pick up from Mars 500 and use on ISS in this annual flight probably. So what is so interesting and precious that we accumulate or received from Mars 500 that we can use in the future? What is the return from Mars 500 that we can use further? David, please.
Very quickly, the fact that we found this hypokinesis and sedentariness, and this is in 1G of gravity, and my good friend Professor Young is sitting there, and when I asked him, when I sent him a draft of the paper and said, we have a simulated space environment, Larry sent back and said, no, you don't. And of course, we didn't have microgravity, and that's right. But what has me worried now is we found the hypokinesis and sedentariness from confinement. That means it can only be worse in the confinement of spaceflight, where you desperately need the exercise. So now I'm a huge exercise advocate, because I'm worried that confinement alone will reduce the tendency to exercise. So that for me was an important lesson. The other one was something that we worked up, Dr. Metaxas, or Dr. Basner and I and our team, the dynamics of behavior and change in physiologic and behavioral functions over time. I'm convinced that what I said the other day, sampling things and looking at the trajectory, rate of change, cumulative functions, tells you the cumulative burden and the extent to which a problem is not being mitigated or corrected, and it's getting progressively worse, and the crew members are separating from each other. And I think that approach to trying to understand the cumulative impact on crew members and the different physiologic and behavioral systems is well worth it, was a lesson to us that that's a good way to think about long duration.
Okay, thank you, David. Let me speak a little bit too. Keeping silence for such a long period is difficult, yeah? You audience, you understand me, huh? You have to listen. Okay, just to begin with, always here in, not here, but there in IBMP, we are making different analogs. And all the time we are listening from some other groups that we are not doing that simulations correctly, that we are not precise, that we're making wrong combination of factors, that results that we have are not relevant, they cannot be reproduced in flight. That's a very different thing. Mostly they're right. Of course, There are ethical backgrounds. I cannot reproduce risks. I cannot make a real microgravity, except parabolic flight, but it's too short. I cannot make many other things in the chambers or in the polar. Still, what I told you today in the morning, in Sphinx, there was a scandal. It was called a scandal. Then one part of the crew closed the door. And I heard from everywhere, you made a bad selection, this was a bad crew, and that will never occur on ISS. Of course, it never occurred yet. But you heard a lot about segmentation. You had some anecdotes about real relationship and about some tension. So, did we made it wrong? I don't think so. I think even if we made it a little bit not that pure, but we managed to see something that is a threat. If we come back to Mars 500, what are the threats that came from Mars 500? Very shortly. First one, selection was very good. But despite that very good selection, as David already told you, the crew tried to escape from each other, to avoid as much as possible any possible conflict situation. There was a big area, big enough to escape. And when we were watching them, we saw that some of them were sitting far, far away from the others. Now, Energia is planning the study on ISS with some sensors put on the uniform to see the distances. And let me tell you, from the point of view of survival that we discussed in the morning, the longer the distances between the crew, the more is dangerous the off-nominal situation, because it's difficult to put them together and act together and escape together. That's lesson number one. Lesson number two, orbital flight is something that ends during landing. Mission to another planet is something that is the crucial point, or the axis, the top event is in the middle. The event of landing changed a lot and gave us the most interesting results. That was the most exciting period for the crew, for the scientists. We never ever simulated that on ISS in any flight. We even do not have any resources or devices or ideas how to do this. But believe me or not, it's difficult to keep fit, to keep patient, if the main event is not at the end but in the middle. Lesson number two. Lesson number three, resources. We talked today about food. It's not the choice between sushi bar and McDonald's. It's the choice between cultural habits. Our Chinese colleague was suffering. The food was not according to his cultural habits. Who is taking care about that if we have international crew? Another point, there was something that they preferred and something they disliked. And the expenditures were different. And there is a limit. There was a limit of any resource. And you can imagine what could happen if resources are really limited, no resupplies. And this is a danger. And the last lesson, communication. Communication is an issue. Now we have problems, but they are moderate. The flights are not that long, and I can't survive talking with these people who do not understand me for a while, or maybe understand me better than anybody else. But the longer the flight, the more communication will be the issue. Because communication is not just talks, there's a sharing of the data. And decision making in the mission control, in the crew, depends upon that exchange. That's the lessons learned from Mars 500. And I think that we have to study these lessons and use them. Next topic, if you don't mind, I want everyone to participate, and I want to start with Professor Gertzer. Are there international analogs we are going to hear about, and the new projects, not just tell me that we have a chamber, we build a chamber. What are you planning to do with the analogs you have? And we start with Professor Gerzer.
Yeah, well, I think there are two kinds of analogs. Inessa said there is dry water immersion and so on. There's two kinds of analogs. One is analogs for missions, which is extremely important, like Mars 500 or using the ISS for Mars mission. That's an analog for mission.
Yes.
But the other analog is analogs for questions. So if we have questions of kind of, we don't know why it's not possible to reliably reduce the bone degradation and that the question is the bone degradation. Now and then we need an analog to test to try to answer questions. And when you come into scientific questions, and usually when you do science, you eliminate confounding problems to make the answer easy or to make it a yes or no answer. And here we come immediately into the question of individualization. What we usually do is we take a number of subjects and then we say, okay, because humans are different, we need 300 subjects or we need 40,000 subjects. But the reason is only that the influencing environmental conditions are unknown, and if we would purely be able to focus on the problems, that I bet you usually we would be able to answer a question with 6 or 8 people. That's the problem, and the problem which is different from physics. Physics is you have laws, and we have humans, and therefore it's a lot of things. So when one wants to answer scientific question in an analog environment, then one needs to be able to do individualization and to standardize as much as possible, and to standardize away so much that only the questions remains. And this is basically the background and reason why we said, okay, we would not want to have an analog facility which would like compete with Mars 500 facility. Exactly. It is built, the philosophy is different.
Absolutely.
So we have an analog facility where we can answer scientific questions, which means the rooms have to be different, the setup has to be different. We have to have everything very close by. So we have in our facility next to the subjects, we have an MRI PET opportunity. Everybody will say, okay, everybody has an MRI PET. But I guess nobody has an MRI which is 10 meters or 5 meters from the subjects, from your closed facility. Usually this is 200 meters away in the basement or in a different building because there's radiation and so on. So what we designed in our facility is to say, okay, what can we do in order to answer scientific questions? And this suddenly gets interesting, therefore, because when we look what is our task for the astronauts and what is our task also in medicine, the task is, for the future, the individualization. We want to get away from the statistics, but we want to know how you function and how I function. And the individualization, we want prevention, we want healthy high performers. Not only astronauts are healthy high performers, I guess some of us here are also healthy high performers. We want healthy high performers remain healthy and high performing. And we have to do telecare. For astronaut is a role model for those tasks. And suddenly we say, okay, what can we in space contribute to this task? As we need individualization, we need the possibility to study the healthy human being in a complex environment. And that's something which only the space community can do, and nobody. We have to learn from genomics and omics, we have to learn. But eventually we need to be able to study the healthy human in order to say, okay, how much does genomics contribute, how much does motivation contribute, and so on. And so for us, it's this facility which we are building is also a link between space and Earth applications, because at the end we want to answer scientific questions. And scientific questions in both ways, how can the space community help the others, and so on. So it's also a linking. And therefore in this facility which we are building now, We are now linking up with excellent scientists which are not involved, even interested in space, but which say, this facility is unique because we can answer our questions. So it's also kind of a linking between the space and the terrestrial community, which, in my opinion, there's no difference anyway. Okay.
Thank you for your wise comments. Игорь Борисович, я еще раз попрошу вас высказаться. А вот что у нас нового появилось с точки зрения аналогов?
To ask another question, what new do we have in analog development? Maybe virtual reality complex. Will you be able to tell us something about that? Me? Yes, you're the best man.
Момент, который действительно несколько был упущен, в частности,
Yes, this is something that I didn't mention before.
Аналогового мышления.
When I was talking about analog thinking, that was virtual reality.
Вот за прошедшее
In
время
fact, recently at our institute,
профессоров Гущина и Бубеева
Gushin and Gubeyev were initiators of, and our engineers were initiators of a simulator for virtual reality, and that simulator allows a cosmonaut to emerge after certain operations or maybe landing to another planet. They would be able to move around on that surface, new surface, in a spacesuit, or maybe using rovers. All of that is virtually simulated. Based on cosmonaut assessments and specialist assessment, those virtual reality systems allow us to be pretty close to what they may actually experience, because physiologically a cosmonaut is able to register various functions and cognitive elements, thinking, memory, all of that is getting involved, and also creative ability in parallel can be assessed in a test mode. So we believe the use of such simulators would allow us significantly to improve analog ideas for interplanetary complex that was used in Mars 500 project, and also that will help us to improve psychological support, so important for long-term 1 year and longer flights, especially interplanetary missions. Those first experiments that I mentioned demonstrated that space operators experience a lot of tension during such responsible steps, and we can kind of assess it length, time-wise, and intensity-wise, and also we can simulate some other situations that may actually occur in reality.
Of course, the person who's working with this kind of simulator understands that they are working with a simulator. However, you can still see some of the changes in their visual and coordination system. Allows us to observe more physiological characteristics and evaluate working in this type of environment. So this type of simulator allows us to become part of this environment. On the other hand, during flight, we can use the same type of simulators to allow a person to experience their time with a family,
in some of their hobbies, be it fishing or gardening or whatever else, which would allow us to reduce some of the tension and reduce some of the difficulty associated with the long-duration mission. So maybe that's something that we could use on the ISS even, and which would allow us to reduce stress in real flight. Virtual reality physiology at the very early stages of research, because we have to look at the changes in cardiovascular system changes, vestibular system changes that we can evaluate using virtual reality simulators, and so forth. So this is a very new direction in our research, which can be a very helpful tool in terms of analog studies, but it's not new. It expands on what we already have. Okay, quote unquote new. It allows us to look at new aspects of human performance and physiology. So thank you. And I would like to say something as well.
Always belongs to NASA, you know?
Я просто снова еще раз хочу сказать о том, что
I just wanted to reiterate
каждая модель
that every model, every analog can give us a lot of benefits when it's used wisely in accordance with its design. And I think the difficulties arise when we start using analogs for something that they weren't designed for, and then the results are not as good and not as expected. So going back to immersion that I was talking about earlier, remember I was saying that it's a great analog. Dr. Gertsen made an excellent statement. Immersion is one of the most effective models. We can use bed rest, we can use immersion, but the advantages of immersion are as follows, because it's a great tool for testing. We can use it as a tool to test a hypothesis or things that we want to use in the future. So immersion is a great tool. It allows us in a matter of days to receive the results or effects that would take months to achieve using bed rest. Can immersion be used to test countermeasures for long-duration flights? I can tell you right away, I'm not confident in that, because during long-duration flights, we have several phases or several stages. The early stage, middle stage, and late stage. So our research showed already that the countermeasures that are very useful and effective in the first stage of the flight are not as effective in the second stage, for example. So, if you need to have a tool to test countermeasures against microgravity, immersion is great for that, for short-duration flights. But for long-duration flights, you have to use something else. There was an immersion that lasted 56 days. You can do that, of course, but it's very difficult. Water immersion is not great for studying motion sickness because there is no motion there. And immersion, dry immersion, when you use a suit, for example, is great for researching motion sickness because a person can move around in a pool, for example, using that special immersion suit. So there are various tools, various opportunities.
I can't avoid at least 3 questions I hope to get to that nice presenters. I hope that there are some questions. We have not more than 5 minutes for this. Yes, please. Yes, you. Валерий Васильевич, ну там первую руку поднял коллега. Вы следующий, ладно?
I'm sure you've probably studied this, but I just don't know the answer. And I guess to David, you would probably know this very well. What happens if you were to just put married couples, say 4 married couples as a crew?
I don't know the answer. It depends on the strength of the marriage and God knows what else.
I don't want to do that kind of simulations, then go to the court for all these formalities.
Yeah, but I mean, in another sense, this has been worked out over a long period of time, and that's where people retreat to.
Yeah, you have to be careful because bond pairs, married pairs, have complementary roles. And you're changing the roles or the role relationships in confinement, so we don't really know. I'm sure some couples would do fine, but some probably wouldn't. So.
Валерий Васильевич, пожалуйста.
Мне бы хотелось спросить у участников панели.
I would like to ask panel participants
к исследованию дальнего космоса.
About space exploration and long-duration flights. What analogs can you suggest to evaluate stress tolerance or whether or not the person is suitable to participate in such a long-duration flight?
May I start? Можно я буду в этом случае говорить по-русски?
I will speak in Russian. If nobody has any objections.
Я понимаю, что я забываю язык. Дело в следующем. Я думаю, что вот модели, о которых начал говорить астронавт
Jacques started talking about, very relevant because they're not models per se. It's not an artificial environment, it's natural. So being in a cave, for example, creates a stressful situation. But you don't have mission control component to that study. You don't have a sense that everything is under control, everything is predictable. So when you use cave analogs or analogs in Antarctica or ESA analogs that we sometimes participate in, thanks to our ESA colleagues, or similar analogs on the submarines, allow us to study things that are already present in real life. However, when we are using chamber analogs, then we have a lot of constraints and limitations related to bioethics. What about selection of candidates for the long-duration flights? What I can say is what you already said before. I don't think that duration per se is a factor. I have to spend more than 2-3 months with a person to say whether or not they can be ready for a mission that would last 2 or 3 years. I don't need to put them through 2 or 3 year-long study. So we're not going to do a study that would exceed 500 days, for example. We did that experiment once, and now we need to make sure that the duration of our experiment is reasonable and select good models for that.
Be adequate. It cannot be ideal. It must be adequate. Adequate to the goals and purposes that you set as a scientist. That's just to answer. One more question and I will finish. Please.
This sort of follows on. David, you pointed out that you need to do these long-duration studies with the right personalities, otherwise you're not really learning from it. On the other hand, as you said, that you can't take somebody who's training for a trip to Mars and take 6 months out of their lives to put them in isolation. So can you use this to actually determine the psychological characteristics such that you learn enough from studying some people that you can then have predictive power for selecting a crew? Because otherwise, what are we getting out of all of this?
So we don't, I mean, I want a disclaimer, I don't do any selection for any federal agencies, but I've done work for all of them. You don't have to go 500 days, even 100. 10 days will do, 20, and all I need to do is control the environment. And I will arrange to increase pressure in the pressure cooker, okay, and then slack off while we watch behavior. What we're looking for is resilience, non-narcissistic responses, people who still have empathy in the context, but are task-oriented, will get the job done. They can't be overly empathic. I mean, there are a set of criteria. Having now had the privilege of studying a fairly large number of people on ISS, the astronaut pool, not surprisingly, has a diverse range of personalities. And there's nothing to say that any one of those personalities is the right or wrong stuff. It's a function of how they'll deal with annoyances, unhappiness, disappointment, emergencies. Will they become impulsive over time, or will they start to develop social isolation, or will they have conflicts when they could easily be discharged? And most astronauts cope fairly well with all of that and deal with it, but sometimes not. And the selection has to be done in a way that, particularly for a long mission, you don't end up with a toxic mix, potentially. I do have some very strong opinions about one of the roles that needs to be among the crew going. I believe we would be really remiss if we did not send a physician. And I'm not talking about a physician just for bone and muscle and heart. I'm talking about a physician for the brain and behavior. I believe we must have a physician on board. The physician can also be the keeper of the personal secrets. They can give the empathy, they can help, and they can have access to the commander for things that might threaten the mission. So I actually think they serve a key role for a long-term mission. But that's my personal view, and it is based on some experience in that. But that individual also has to have the right makeup.
Good bedside manner.
Well, it's tough empathy, okay? It's a balanced, it's titrated, just the right amount.
Not in the meaning of Carl Rogers, of course.
No, not in the meaning of Carl.
Let me finalize our session and thank all the panelists for very interesting presentations. I believe they were interesting for you. Thank you very much.
I should have said mission fellows, of course. The science analysts, that's a key